Learning the C programming language offers significant advantages, especially for those looking to build a strong foundation in software development. C provides a deep understanding of how computers work at the hardware level, making it ideal for systems programming, embedded systems, and performance-critical applications. With C, you'll gain control over memory management and improve your problem-solving skills, enabling you to work on more complex projects. At Pacta, we offer comprehensive training that covers the essentials of C programming and beyond. Ready to enhance your coding skills? Join our Pacta training courses today and take the first step toward mastering C and becoming a proficient developer. Ready to take your business to the next level with expert no-code solutions and strategic consulting? Contact Alan Stevens today for personalized guidance. Visit Pacta.com to learn more about how we can help you streamline your operations and protect your business. Don't forget to follow Pacta on social media for the latest updates, tips, and insights in automation, AI, and business development.
Ever wonder how we went from those massive room-sized computers to having, the entire world tucked away in our pockets?
It's mind-blowing, right?
Totally. And today's deep dive is all about a programming language that's been kind of secretly running the show behind the scenes for decades. C, the code that built operating systems, the backbone behind, pretty much every app we use every single day.
Absolutely.
We're going deep into those excerpts you sent over from Programmation C and that Introduction to Langage C to uncover what makes C so incredibly powerful and, maybe even a little bit, shall we say, infamous.
Yeah, it's got that reputation, doesn't it? What fascinates me about C is that it's like this hidden bridge between the software we use, all those shiny apps, and the nitty-gritty hardware it all runs on.
Okay, now you're speaking my language, but maybe break it down for me, like I'm just starting out here.
Sure thing.
These guides mention things like central memory and CPUs, and honestly, I need a little refresher on what those even are.
So imagine central memory, or RAM as it's often called, as your computer's mental workspace.
Okay.
It's where data hangs out temporarily while your computer's actively using it.
Got it.
Then you've got the CPU, the real brain of the operation. It's constantly fetching instructions from that memory and executing them. It's like the tireless worker bee, making absolutely everything happen.
We interact with all of that through our peripherals, things like our keyboard, mouse, monitor.
Right, exactly.
Yeah.
There are communication tools.
Yeah.
We send commands using the keyboard and mouse, and we receive feedback through the monitor. But to manage all this hardware and make it, somewhat user-friendly, we have the operating system. Your Mac OS, your Windows, that's the OS.
Right, the OS. But how does a programming language like C actually tell the OS what to do? I mean, it's not like we're just typing in plain English into Notepad and hoping for the best.
That's where things get really clever. C has its own unique set of rules, its own syntax, just like any other language.
Yeah.
And to make those instructions understandable to the computer, we use something called a compiler.
A compiler.
Think of it like a translator. It takes our human-readable C code and magically turns it into the binary language of zeros and ones that the computer's hardware can actually understand.
So the compiler's like what? The Rosetta Stone of programming? Taking something we get and making it digestible for the machine?
Precisely. Without that crucial translation step, our code would just be gibberish to the computer.
That makes that classic Hello World program example in the Introduction to Langage C guide even cooler now. It's like our first successful message sent across that human-machine divide.
It really is a rite of passage for every programmer. That simple program, as simple as it seems, demonstrates how we use C to display output, and it introduces us to the structured nature of the language itself.
Structured meaning?
C likes things organized. You write your code in blocks, you use very specific syntax, and very importantly, you declare what kind of data you're working with up front. It's a lot like, when you're in the kitchen and you label all those canisters so you don't accidentally mix up your sugar and salt.
Wait, labeling canisters? How does that even relate to C programming?
Well, in C, you have to declare the type of data a variable will hold, things like an integer, a decimal number, or just a single character right from the start.
Right.
This is how the compiler knows what kind of information it's dealing with and what operations are allowed.
So if I, tried to store an entire word in a variable that was meant for just a single letter, the compiler would basically throw a fit, right? Like me trying to cram flour into a salt shaker.
Exactly. It's all about setting those clear expectations from the start. Just like those labeled canisters make your life so much easier in the kitchen, these data type declarations do the same for your C code.
All right, that makes sense. It's interesting, though, you said C wants us to declare these data types up front. The Programmation C guide uses the term statically typed for this. Why is that such a big deal in C? Wouldn't it be easier to let the computer just figure it out as it goes?
You think so, but here's the catch with that kind of flexibility. It often leads to hidden errors that only rear their ugly heads way later down the line.
Uh-oh.
By being super strict about those data types from the get-go, C actually helps us catch these potential problems early on during that compilation stage, rather than having our program crash unexpectedly when we're in the middle of something.
Gotcha.
It's a trade-off, a bit more upfront work in exchange for way more predictable and reliable code.
So it's like choosing to be organized from the get-go to avoid an even bigger, more painful mess later on.
Precisely. And this real attention to detail, this explicit, it's woven into the very DNA of C.
Interesting.
Now let's dive into those data types themselves a bit more.
Data types, the core ingredients in our C programming pantry, right?
I like that analogy. And just like in a real pantry, you've got your staples.
Yeah.
You've got your integers, those whole numbers like 10, 25, a million, whatever you need. C represents those with the keyword int.
Makes sense.
But here's where it gets even more interesting. C lets you get really specific with these modifiers like short, long, unsigned.
Okay.
It's kind of like choosing different size measuring cups for your ingredients, depending on what you're making.
Ah, so it's about picking the right tool for the job, making sure you have enough space to store those numbers without being wasteful. Practical.
Exactly. And then, of course, you've got your floating point numbers, your decimals like 3.14 or 9.81, all those numbers with a bit of a fractional flair.
Right, right.
For those, you've got float, double, and even long double, each offering varying levels of precision. Think of it like using a ruler with finer and finer markings if you need those super accurate measurements.
I'm with you. Now, what about individual letters, symbols, that kind of thing? That's got to be important for any programming language, right?
Absolutely.
Yeah.
For those single characters, C uses the char data type, nice and straightforward. Now, strings, those collections of characters that make up words and sentences, that's where C gets a bit unconventional.
Unconventional how so?
Well, C doesn't actually have a dedicated string type. Instead, it represents strings as arrays of characters, basically, like a chain of individual char data types all linked together.
Okay.
And here's the real kicker. The end of a string is marked by this special null character, kind of like tying a knot at the end of that character chain to signal, okay, this is where the string ends.
So instead of having some like fancy pre-built string container, C is giving us the tools to build our own strings brick by brick with characters.
That's the C way. It might seem like extra work at first, but this kind of flexibility gives programmers amazing control over how strings are actually stored and manipulated in memory, which is super important for things like, building operating systems or working with those resource-constrained devices where every byte counts.
That makes sense, especially given C's reputation for efficiency. But all this talk of storing data makes me wonder, how does a C program actually decide what to do with all this information? It's not just about storing ingredients, it's about following the recipe, right?
You're right. That's where control flow comes in. Think of it like the set of instructions that guides the program's entire journey. It determines which lines of code get executed and in what order, like following a map with all its different paths and intersections.
And those paths are determined by conditions, like if this is true, go this way, otherwise go that way.
Exactly. C uses if, else, and even switch statements to create those decision points within the code. It's how we programmatically make choices based on the data we're working with at any given time.
So like using our recipe analogy, it's like saying, if we have eggs, make a cake, else make pancakes.
You got it. Now imagine you need to repeat a step in that recipe multiple times. That's where loops come in.
Loops.
They let us execute a block of code repeatedly, which is incredibly useful for tasks like, say, processing a whole list of data or performing some sort of calculation over and over again.
Right, right. The Introduction to Long-Arch C guide, it actually mentions 3 different types of loops: for loops, while loops, and do while loops. What's the difference?
So think of the for loop as your trusty kitchen timer. You know exactly how many times you need to repeat something, so you set that timer and the loop runs until the time's up.
Okay.
So if you needed to stir a pot for exactly 5 minutes, you'd use a for loop to repeat that stirring action 5 times.
Gotcha.
Ready to take your business to the next level with expert no-code solutions and strategic consulting? Contact Alan Stevens today for personalized guidance. Visit Pacta.com to learn more about how we can help you streamline your operations and protect your business. Don't forget to follow Pacta on social media for the latest updates, tips, and insights in automation, AI, and business development.
Now, a while loop that's more like watching a pot of water until it boils.
Yeah.
You don't necessarily know how long it will take. You just keep an eye on it until a specific condition is met. In this case, the water boiling.
So it's about repeating something as long as a certain condition remains true. Like while the water's not boiling, keep heating it.
You got it. The while loop keeps going, keeps executing that block of code, as long as that condition, in your example, the water not yet boiling, remains true.
And a do-while loop.
The do-while loop guarantees that the code block executes at least once, even if the condition is initially false.
How so?
It's like saying, take one bite of this delicious cookie, and then, if you like it, which, of course, you will keep taking bites until it's gone.
Okay, so the do part ensures at least one bite, one execution happens right off the bat.
Precisely. Now, I can see how these loops can prevent us from writing the same code over and over. It's like automating those tedious, repetitive tasks.
Right.
But as our programs grow larger, more complex, how do we keep everything organized, manageable? I'm guessing this is where functions come in.
Yeah, functions. It's like having that whole drawer full of specialized kitchen gadgets, each one perfectly designed for a specific purpose. We can use them whenever we need them, keeping our code nice and clean and efficient.
Exactly. And just like those gadgets come with a little instruction manual, functions in C have these things called declarations and definitions.
Okay, so walk me through that.
So the declaration, that's like the label on the box, right? It tells the compiler what the function is called, what kind of output it's going to produce, and what ingredients or parameters in programming lingo it needs to work its magic.
Right, makes sense.
Then you've got the definition, which is like the actual blueprint inside. It outlines step by step how the function actually does its magic, how it takes those ingredients and produces the final result.
So it's all about being organized, being clear about what each function does. But there's one concept from these guides that, I'll be honest, still makes me a little nervous. Pointers. It seems super powerful, but also a bit like, juggling chainsaws.
Pointers, yeah, they're definitely one of C's more challenging concepts to wrap your head around.
You think?
But once you grasp them, it's like you've unlocked this whole new level of control over your programs, It's a bit like, imagine you have a treasure map.
Okay, I'm intrigued.
Instead of the map directly showing the treasure itself, it just points to its location. That's essentially what a pointer does in C. It holds a memory address, a direct reference to where a piece of data actually lives in the computer's memory.
So instead of lugging around this heavy treasure chest everywhere, we're just carrying this lightweight map that tells us exactly where to find it.
You got it. And this ability to actually work with memory addresses directly, that's what makes C so incredibly powerful, especially for things like managing resources super efficiently or writing code that needs to interact directly with the hardware itself.
But, like you said earlier, there's a reason for my nervousness. The Programmation C guide, it mentions things like memory leaks and dangling pointers, which honestly sound like potential recipe disasters.
They're definitely things to be mindful of. A memory leak is like accidentally leaving the faucet running.
Okay.
You've allocated some memory for something specific, but you haven't released it when you're finished with it. So it's just sitting there unused, wasted, and a dangling pointer. That's like having a map to a treasure chest that's already been dug up and moved somewhere else.
Oh.
It's pointing to a location in memory that's no longer valid, which can cause really unpredictable, really weird behavior in your program.
So it's like those cautionary tales, right? With great power comes great responsibility. C gives us this incredible level of control, but we'd better use it wisely.
Precisely. Careful memory management is absolutely crucial when you're working with pointers in C. Now, we've covered a ton of ground here, from those basic data types to the, shall we say, more intricate world of pointers and functions.
Right, and don't forget those loops.
Absolutely. But these guides, they also touch on even more aspects of C, like structures, unions, and file input-output, which are all fascinating in their own right.
It's true. It does feel like with every concept we unpack, a new door opens to even more possibilities. It's a bit daunting, but honestly really exciting at the same time.
It really is. That spirit of exploration, that's what makes C programming so rewarding. Take structures, for instance. They let you create these custom data types, combining different pieces of information together. Like, imagine grouping a person's name, their age, their address, all under a single person type, super organized.
So structures are all about organization. What about unions? What makes them special?
Unions are kind of about efficiency. They let you store different data types in the same memory location. But here's the catch. Only one of those types can be active at any given time. It's like having a multi-purpose room that you can transform based on your needs, whether it's a guest room, a home office, or whatever.
So structures are like those well-labeled kitchen canisters, and unions are like that multi-purpose room that adapts to the situation.
I like it. You're getting it. And then, of course, there's File I/O, which lets your C programs actually interact with external files. This is how you save data permanently, how you load information from the outside world. Think of it like reading a recipe from your favorite cookbook. That's File I/O in action.
All these possibilities, it really makes you think, is C ever not the right tool for the job?
That's a great question. And while C is amazingly versatile, its real strength, that low-level control and efficiency, can sometimes make it, well, a bit more complex than necessary for certain tasks.
How so?
There are certainly other languages out there that are better suited for things like, say, web development or data analysis, where you don't necessarily need to be down in the weeds of memory management.
That makes sense.
But for tasks that require that deep connection with the hardware, or where performance is absolutely critical, or when you need that super fine-grained control over memory, C, it's still a really powerful choice.
It's clear that C has left an undeniable mark on, well, pretty much the entire programming world. What advice would you give to someone who's just starting out on their own journey with this language?
I'd say be patient with yourself, with the learning process. C's power, it comes with a bit of a steeper learning curve than some other languages out there.
For sure.
Embrace the challenges. Don't be afraid to make mistakes, to experiment. And always remember, every single expert programmer out there, every one of them, was once a beginner, staring at their screen, writing their very first Hello World program.
I love that. What a journey this has been. We've explored these core concepts of C, from those fundamental building blocks of daily ups and variables, all the way to those more powerful features, your pointers, your functions, your loops. You've given our listener a really solid foundation for understanding not just the what, but also the why behind this incredibly influential language.
It's been my pleasure. And remember, everyone, this deep dive, it's just the beginning. The world of C is vast, it's fascinating, and it's ripe with all sorts of opportunities for learning, for growth, and, yeah, let's be honest, probably a little bit of head scratching along the way.
That's part of the fun, right? So to our listener out there, keep that compiler running, keep experimenting, keep exploring. Who knows what you might create? Maybe you'll write the next piece of code that shapes the digital world as we know it. Until next time, happy coding, everyone.